Algebra 2 kids are really taking the time, right? Ashwik, I know. I know. It's always a big class. Okay, let's move on. What did we, Jay, what are they doing in school?
We're doing dot plots with mean, median, mode, and range.
Dot plots with mean. You know what? Did we cover it last week? I'm a
Yeah.
little off, guys. We covered it last week, right? Already?
Yeah.
Yeah.
V78 advanced. Okay.
think
No,
those
not this.
box
Uh-huh.
plots did.
Go ahead.
I think that was box plots, the one that we did.
Yeah. So I, 1 second. Yep, plot comparison we already did, right? Okay, and what are you doing in, let's see. Last year's coming in. Lakshmita, what are you doing in school? Lakshmita, what are you doing in school, ma? Quick, come up.
We're learning about equations.
We really want your voice to be better, ma. Nothing is heard. Mitransh, what are you doing in school?
We just finished our unit test for 3D volume.
3D volume, but plot comparison? Plot comparison, you didn't do it at school, right?
No.
Okay. Okay, how about Riddha and Vikyat? What are you doing, guys, in school?
We're doing mean, median, mode, and range and dot plots, but today we did the test for algebra to get into algebra.
Oh, IAC, huh? How was it?
It was okay.
Okay, I see. It was okay means it was hard, easy, something.
Yeah, it was a mix of both.
Okay. Okay, guys. Can you give me a second? 1 minute, guys. I'm asking whether I can stay here. Okay, guys, let's go ahead. How was the plot comparison homework? Did you have any questions on that, guys?
No. I think I had one.
Okay, let's go ahead to that and then we'll see. Some people are joining still, really. Okay, Sayush is coming in. Okay. Okay, I'm sharing, guys. Go ahead and ask.
It's the first one.
Go ahead.
It's like the first assignment.
Okay, let me share.
One that had 60 questions.
This is the one, right? Plot comparison.
No, it's the other one.
Is the previous week's homework you're saying?
It's let me check my equations and inequalities.
Equations and inequalities. Okay. Okay, so you're looking, okay. Ashwik, are you in the other class?
No,
Did you switch class?
no,
Oh, this one?
yeah,
This one?
yeah. Question number 60 for me.
Question number 60?
Mhm.
Sure. Can I do that on the board directly, quickly?
Yeah, I got like a weird answer.
No problem, Mark.
I
I'll do it
got
on the board.
P was like it said -8 is greater than 12.
-8 is greater than 12. Then what? Okay, let's see what
That's
I
what I
get.
got.
Okay, can I try?
Yeah.
2 plus 18p Then you have to distribute the minus. Remember, the minus has to be distributed to this. And then plus 10 greater than 12 plus 16p. So what happens here? 2 plus 16p plus 10 is greater than 12 plus 16p. Then the next one, yeah, subtract 16p on both sides. So what do you get? 12 is greater than 12, I am getting.
Oh, yeah, my bad.
Yeah, so what is this? Is this an acceptable mathematical inequality? 12 should
No,
have been equal to 12. So this is completely invalid, right? So when you arrive at something that is completely invalid, right, you can clearly say that there is no solution for P. That means if you, whatever number you substitute for P, the given inequality is never going to work. Make sense? Ashwik, does that make sense?
yeah,
So see here, no solution. There is no solution for P. That means whether you substitute P equal to -1, -2, -3, -4, -5, -1.5, 1, 1, 2, 3, 4, 5, 6, 0, anything you substitute for P, the inequality is going to be invalid. That is a scenario where you say, hey, P does not have any solution at all for this given inequality. Make sense?
yeah.
Okay. Suppose, let's say there are cases when you solve this inequality, you can get something like 4 equal to 4 or 4p equal to 4p. This is very valid. If you arrive at this, you cannot find the value of p at all, right? So you can say all real numbers. Any number will work. Any real number, if you substitute for p, will work if you arrive at a valid statement. Does it
Mhm.
make sense, guys?
Yeah.
Let me see whether I have examples of that. I wish I had though. Other one? Mhm. Okay. So I don't have examples, but if you arrive at a valid statement, guys, then in that scenario, you can say all real numbers. But if you arrive at an invalid statement, like 12 is greater than 12, doesn't make any sense, right? Then there is no solution. Any questions? Any other questions you had?
Mhm.
Any other questions? Any other questions anybody has?
I don't have any.
Okay, can I go ahead with
I had one question. I'm trying to look for which one it was.
sure. Okay, just look and quickly ask.
I found it, but I saw what I did and why I had a question. I just saw.
You have it? Can I write
Yeah,
it
but
down?
I found out what I did.
Okay, good. Vikya, did you have any questions? Anya, did you have any questions, ma?
No.
I didn't have any questions.
Okay. Did you work through the homework, Anya?
Yes, I did.
And Sayush, I really want you to prepare for Noyotic this time, Sayush. Can we? Sayush.
Yeah, sure.
Yeah, I really want you to be able to prepare for Noyotic based on the papers that I share with you. Make sense?
Wait, there's papers that you shared with me.
Papers I'll share with you, but go, I want you to prepare is what I meant to say. Got it? Got it. Just like that, registering and coming and attending the test doesn't help. Meaning, I want you to work out those sheets and please send it to me in WhatsApp. I will have a look at it.
So did you
Makes
send it already? Or
No, not yet.
okay. Got
Does
it.
yeah, does it make sense?
Yeah.
Okay, let's see this one. 1 minute, guys. So we did 1 second, guys. So hold on. So we want to get into probability slowly, but a minute, wait. So I'm going to go ahead and talk to you about. See, I really want you to use data from a random sample to make inferences about population. One thing which I did not say right last week, I really wanted to know how you guys solved the problem, because in the other class, the same was asked as a question to me. But in your class, nobody asked me, and I was wondering how you guys did it. Or let me show you what was that question. Let me ask you that question so we'll know. Okay, this was the question, guys. I'll go ahead and give you this question. I don't know whether we discussed in class, but it was little unfortunate for me when I saw that nobody asked this. Did you do this problem, guys? Did you do this problem? Did you do this problem?
No.
It was a part of homework, right? See, this is where I felt, hey, what's going on in your class?
I think I remember doing it, but I don't remember completely.
Yeah, no,
Because I didn't discuss.
I did this problem.
Yeah, you did this, right? So
Yeah.
we didn't discuss about sample data and inference, right? We never discussed what is sample data and inference, right?
I learned this in my math class, so I know.
Ah, I see.
Oh, yeah, I did this question.
Yeah, I did it.
So how did you
I
guys do?
remember this.
Yeah, I know. Okay. How did you guys do? How were you able to figure it out?
Define IQR. Like, is it what, like how to solve it? What are
Yeah.
you asking?
No, how did you solve this? Meaning, what is the relationship between any sample data and inference? Inference means the conclusion you make, right? I never discussed this concept at all. So I was a little taken aback. How did this group of students do was my question when I confronted this. So what is the connection?
I did English, and then I did English was 80, and then history was like around 87-ish. And then I did
Dilemma. Okay,
median.
Ashwik.
No,
Ashwik, what I want to know is, how do you say? See, it clearly says the strength of inference. What is that?
I put H as the answer
But
because
why?
because the median of English is 80 and 80 is the average. So people are more likely to score 80 in English because the average is 80 for English.
Oh, okay. But how did you decide on this? Okay, students are more likely to score below an 80 in English than in history. In English than in history. Okay. But why did you choose that? Then how did you decide? What is inference is strong, inference is weak? What is all this?
I got G.
Okay. So are you all checking your answers?
Yeah, I got H.
Yeah, guys, see, more than you
I
getting
got
G or H.
H.
Okay, guys, I really want to understand what is sample data and inference. Who can explain? Anya, how did you do this, ma?
I wasn't sure how to do it, so when I was doing the homework, I asked my dad for help on this one.
So how did you do?
So I did what Vicky said. I found the average, and then I circled the answer that I saw the average.
Oh, but see, but there is also something called the strength of inference is strong. The strength of inference is weak.
Yeah, my answer was partially guessed too.
Okay,
Because I didn't know
See,
what that meant.
if you
'Cause
have
I
something
don't
like
know
that-
how to do the strength of inference.
Okay,
The
guys,
sample data inference is like, isn't it like a conclusions like about large?
inference is the conclusion you draw. Correct. Okay. When will your conclusion be strong or weak? Okay, let's see this one. Strong or weak. Suppose, let's say there is a survey. Okay. Meaning, let's say there are 500 people in a village. Okay. In a village. Okay. I'm conducting a survey. Who likes to eat in the restaurant? Who likes to eat at home? Okay, I'm conducting a survey between these two types of people. Of the 500 people in the village, I'm taking 200 or let's say 100 samples, 100 people inputs I'm getting. Randomly, I'm taking them. Randomly, I'm taking 100 people and asking them, hey, do you like to go to a hotel or do you like to eat at home? That question I'm asking all the 100 people. So basically, in this data set of 500 people, this 100 is my randomly chosen sample, random sample. If you choose a random sample, or you know what I could have done? I could have just chosen the men in the village. I chose the men in the village, 100 men in the village. If I do this, am I doing it correctly? Or if I do it at random, which is correct? Which is correct way of doing it? What do you think? Choosing 100 men in the village and asking them the survey question is better, or choosing 100 random people in the village and asking the same question, getting a conclusion is better?
Random people.
Random.
Exactly. If I
Because you
ask
get a
only
wider range of answers.
exactly, so I will get a better representation of the actual population in this case. So this sample taken is a biased sample. I'm only supporting the men now. I'm against women. No, it's a biased sample whatsoever. But random sample is an unbiased sample. Makes sense? So this is better. So this is what is all about random sample. Random sample is always better with respect to sampling. Okay, randomly you have to ask people for surveys and get conclusions and make inferences. Okay, now let me say this is one scenario. I said you have to take an unbiased sample. Okay, the other scenario is, you know, the village is 500 people, right? One is I can choose only 5 random people. I'll choose 5 random people and ask the same question. The other scenario is I can take up 150 random people. Which is better? Which will get a better representation of the people? People's perception.
150 random people because you'll get more
Both are random.
opinions.
Both are unbiased. This is also unbiased. But what did I do for the 500 people, 5 people? It's 1 by 100. Do you see this one? Whatever conclusion you attain, right? Inference is very weak. Why? Because the sample size that you have taken is very less. Whereas in this scenario, where the sample size is quite huge, 150 of a 500, that ratio is bigger, better, right? In an unbiased sample. So here, the inference is strong. Any questions, guys? Any questions? So when do you get a strong inference? Whenever your sample size is a lot more compared to the actual population. Okay, 5 out of 500 is 1 by 100. It doesn't represent anything. The 5 people may not represent the general population at all. Lasya, are you with me? Okay. Whereas if you choose 150 people out of 500 is very good. Any question for me here?
No.
Okay. So, okay, coming to this question. Now let's read this question. This question makes a lot more sense. There are 264 students and he's picking up 75 grades. Is it good? Is it a good size? Of the 264 people, 75 is a good number of samples. So the inference will be strong. The sample size is huge and the inference will be strong. So answer can be this, answer can be this. But let's say 70, let's see, 70 is where 70 is in here. So 25% of English is less than 70. Okay, here this is less than 20%. So what does it say? Students are more likely to score below a 70 where? In English, actually. No, it says in history. So this is incorrect. How about the students are more likely to score below a 80? Let's take that 80. This one is 50%. This one is less than 50%. Below 80 is 50% in English, less than 50% in history. Students are more likely to score below 80 in English. Yep, that's right. Than in history. The strength of, so answer is H, guys. Any questions? Any questions, guys?
Is the is like the likeliness of someone scoring 80 in English, like less than 80 in English, because
80 is here, Amma.
yeah, it's the thing is pointing to 80, but
This is 25%.
I thought it was G because I didn't know what the inference strength of inference was before. So I put since I thought like the history had like a higher range, people would score um better in history.
Yeah, Rida, but here, see, each is a 25%, right? 4 quarters, right?
Yes,
This is 25%, this is 25%. So 80 means 50% of the people are scoring less than
80.
80. In history, how much percentage is this? This is the first, this is 25%, and
Yes,
this is another 25%. So the number of people less than 80 is 25 plus half of 25. You see? So it
yeah,
is much less than 50%, less than 80. You got it?
yeah,
So less than 80 is being scored by more people in English only. You got it?
yeah. No, I thought because the range is bigger, so I thought more people would get like a less score and like
The range does not determine that. You have to calculate how much percentage in each quarter.
yeah.
That's what is the specialty about the box and whisker plot.
Okay,
Make sense?
yeah.
Okay. So this was one question which I did not teach. I felt bad, so I brought it up. Any other questions anybody has? Can I move on? So this was one concept that we did not cover. Any other questions? Can I move on with my own?
Yes.
Okay, good. We did start probability. I know a little bit we did, but wait. 7.6, I don't want to start, but how about this? When probabilities of a simple event, plot comparison we did. Okay, let's see this one. Hold on, guys. I just want to make sure what I want to do. Yeah, so I don't know how many are there in this. Let's see. This we did actually. Okay. No, I don't want. Yeah. See, these are miscellaneous topics in 7th. I really want to do it slowly. Let's see. Okay, how about this? These are again plot comparison, guys. It's a little, let's see. How about this? How about this? You can go ahead and try if you're stuck. Anya, did you understand the last problem? Inference, sample data, all that stuff?
Yes, I did.
Okay. If you're not getting it, stop me, Anya.
Okay.
Yes, Ayush, please go ahead and come back quickly. So here, middle school is an enrollment of 80 students. He randomly selected a group of 40 students from his middle school about their favorite ice cream. Yeah, this one is a good one. Based on these results, which inferences can be made about the number of students in Cole School who would make cookie dough as their favorite ice cream flavor? This one, do you know how to calculate the percentage, guys?
Yes.
Okay, good. Then you can all do it by yourself. I feel this one is an easy one.
Do I just send the option numbers?
Yeah, would love to.
Okay.
We discussed sample spaces, right, guys? We solved a puzzle on probability. Am I correct or not? Did we do? Jay, did we do some probability work a few weeks back?
I think we did.
Yeah, I think.
Okay. So we discussed. Okay. Good. Okay, that's good. So we have covered several of the. Mm-hmm. So this week, your homework will really have questions on probability too. Okay. Assuming you're going to send me the answers. If you don't understand, you have to let me know, please. You can say 1, 2, 3, 4, 5. Just answer. Mm, I don't know. Many have answered. I'm a little thrown off. Yeah, Lasya, you got it right. Jay, you got it right. Lakshmita, select 2 answers, right, ma? You have answered only 1.
Did I get it right?
Anya, good job, Anya. The rest of you know. Nidhi, is 4 really correct? Can you check? Adyan, is 1 really correct? Can you check?
Is mine right?
Yeah, Ashwik, where is your answer? Varad, is 2 really correct, you think? Can you check? Sayush.
I changed my
Lakshmita,
answer, so can you check?
yeah, guys, several of you are, it's falling apart in this. I thought, Mitransh, what is your answer?
Is mine
I'm
right?
thinking.
My,
Hmm?
Is mine
mine
right?
is
Yes, Ashwik is right. Vikyat, yes, Vikyat is right.
Did I
Miss
get it
Priya.
right?
Lakshmita, no, ma. Sayush, no.
Miss Priya.
Miss Priya, is mine right?
Varad, yes, your answer is correct. Ashwik is correct. Rida, I'm checking Rida. Rida, yes, Rida.
Okay.
That's right. So basically, I'm not sure why some of you have gotten 2. Some of you have gotten, yeah, some of you have gotten 2 and 4. Why?
Because 2, I think they messed up chocolate chip for chocolate.
Ah, see, this is chocolate chip, right?
Yeah, because like they just see the chocolate and then they go straight to it.
I see. So Lakshmita, can I get your answer? Sayush, yes, Sayush, I think that's right. What is F, Sayush? There are only E option. I'm a little off,
Oh, yeah.
Sayush.
In because in school they usually like skip E,
Oh,
so
I
I
see.
just did that by it.
Yeah, I
Like
got it. Your answer is correct though. Yes,
Oh.
Vikya, that's right. So guys, here answer is 3 and 5. If you don't get it now, please raise up and let me know. This is just calculating the percentage, right? Cookie dough, what percentage of the people liked it? 10 divided with the total. Total, what will you do? 20, 24, 34, 40. So cookie dough is 10 by 40, which is 25%. Makes sense? Chocolate chip, the strawberry is 4 by 40, which is 1 by 10, which is 0.1 or 10%. So like this, you calculate the percentage and read through whichever matches you need to choose. Anybody, any questions? Nidhi, did you get it, ma?
Yes, I did.
Okay. If you want me to do the problem, definitely ask. This one was easy, I thought, so I'm not doing it on the board. Okay, let's try a few more. You should be able to nicely compare any plot given. Let's see. How about this? I would like to hear your inference. Let's see. Okay. How about this? I want your inference on this. See, looking at the data and coming to inference, concluding things is also very important. So a random sample of 200 community members was surveyed about their favorite restaurant. The survey results are recorded in the table.
I said my answer.
I don't want strong or weak inference. Okay. We don't know the actual sample size. How will you get, guys? See, 200 community members were picked up. That's great. Okay. Sample was 200. Out of how many people we don't know. So you cannot say whether it is strong inference or weak inference. Okay. Leave all that. I just want to know what is your inference on this data? Meaning you can compare how many people are like Ami's sandwiches, Billy's burgers, Carl's pizzeria. You can see, I can clearly say, hey, there were 4 times as many people that preferred Billy's burger than Carl's pizzeria because 9% versus 36%, right? Oh, yeah, I like Anya. Yes, approximately twice. Yeah, Lakshmita, very good inferences. See, one inference that came up was approximately twice the number of people who like Carl's pizzeria like Ami's sandwiches. I really like that. Yes, that's one good inference made. And another inference was more people like Diana's Diner. Okay, and not a lot of people like Carl's Pizzeria. That is fine, but I would like to have some statistical data 2 times, 4 times. So some sort of this comparison between the 4 places is a good inference. Can I move on?
Can you check my answer real quick? See?
Yes, Ayush, that was 2 times. Yep, that's right. Whatever you've given is right. Okay. So you should be able to make nice inferences from the given data as well. Mm. How about, okay, we'll go to sample space, guys. Okay, remember, I don't know how many of you remember, but I'm going to go to sample space. Go ahead. Mary is conducting an experiment in class. She wants to determine the probability of getting 3 heads when flipping 3 coins. A penny, a nickel, a dime. Represent the sample space. Do you remember or do you want me to show you? Guys, please answer.
It would be
don't.
like it'd be 2 cubed, right?
I want the sample space, right? I don't want anything. I just want this.
Okay.
I'm not sure
Uh,
how to do this.
I'm not
We can-
sure either.
Were you there in the class where we discussed sample space?
I don't remember.
Is you're all confusing me. Okay, otherwise then I need to go back. Hold on. I'm going to stop the share. Did see in one class I covered it, so I need to know which class. Hold on,
Miss
let me
Priya,
see.
can I use your restroom?
Yeah, please go ahead. Hey, in your in your class I have not covered. Oh, I see. I see the problem. Okay. Okay, then let's go to probability. Slowly we'll go. Okay, so this is not the problem we want to solve. Let's go to the basics of probability. Okay. Now, probability is the chance of an event happening. Okay, meaning we are getting to start probability. Okay, so in your class, it wasn't covered. Since we have covered inferences, sample data, and plot comparisons, I would really like to go to probability. Okay, now probability is a chance of something happening. Hmm? Now we have to learn a lot of definitions here. Okay. Suppose I have a die, 6-sided die that has numbers 1, 2, 3, 4, 5, 6 on each side. Now, if I ask you, probability of an event is given like this. Probability of an event. This is how it is written. Okay. Now, E indicates event. P indicates the probability. Now, when you think about it, right? Let's say probability of throwing a 1 is what, Sayush, in this die? Probability of throwing a 1 is what in this die? So basically, number of probability of an event can be defined as number of favorable outcomes divided by the total number of outcomes. Number of total outcomes. So how many total outcomes are possible in this, Sayush?
6.
6. So what is the probability of throwing one? Favorable outcome is 1 means what is the number of outcomes that result in 1? Only 1. So answer is 1 by 6. What is the probability of throwing a prime number? What is the probability of throwing a prime number? What is the probability of throwing a prime number?
Is it a 50% chance?
360 at 50%.
Think about it. Why is it 50, Sayush?
Because there's 3 prime numbers
Wait,
out
oh.
of 6.
Oh wait, I think I know. Is it 60% chance?
What are the prime numbers, guys?
1, 3, 5.
5.
1 is neither prime nor composite.
Oh,
2 is
3
prime.
and 5.
3 is prime.
Oh yeah, I forgot.
5 is prime. So what is the number of favorable outcomes is just 3. 1 cannot be taken as prime or composite, and that is very important in geometry to know that. And
So
for next,
right?
yeah, and for next week, you all know about a deck of cards, huh? You all have done the deck of cards, meaning seen the deck of cards, played with it. Who has not done it? Can you raise your hand using the raise hand button? Who has not played with a deck of cards? Okay, so everybody. Okay, good. Everybody has played. So probability of a prime number is 3 out of 6, which is 1 by 2. Now, probability of an even number is what? Please in chat. Probability of an even number is what? Guys, I hope you're all getting it quick. Ma, please simplify and give. Anya, how is it 3.5, ma? See, when you calculate probability, do you observe one thing?
No,
It is always
I didn't mean 3 and 1/2. I meant 3/6.
I'm sorry. Okay. 3/6 or 1/2. Correct, ma. So when you think about probability, when you answer right, you should always check whether the fraction that you're giving is less than 1. Remember that. So it should always be less than 1. And the sum of chance of probability of 1 plus probability of 2 plus probability of getting 3 plus probability of getting 4 plus probability of getting 5 plus probability of getting 6. Probability of all the outcomes will be 1 by 1. So when I add all the probabilities of all possible outcomes, it should add to 1. Jay, am I making sense?
Yeah.
Okay. So what did we learn now? Probability, event. Event, what is the event here? Event is throwing a prime number. Event is throwing an even number. Probability is the chance of that occurring. Now, when I throw the same die, right? What are the possible outcomes? You see what is the curly braces I use, right? When I use the curly braces and write out what are all the possible outcomes, right? This is the list of possible outcomes, right? So this type of writing all the possible outcomes in curly braces, then I'm writing the sample space. Now, there is a coin, okay? There is a coin, okay? How many sample space are there in this? When I flip the coin, what is the sample space? When I flip the coin, what is the sample space?
There's 2
Heads and
sides, so
tails.
1 and 2.
A coin can have what?
Heads and tails.
Yeah. So that's the sample space. Any questions? Okay. I have a spinner. Okay. Red, blue, green, yellow. I spin the spinner. What is the sample space?
Red, blue, green, and yellow.
Yeah. Whatever I'm discussing here are all simple events. There's nothing complicated about this. You either flip a coin or throw a die or spin a spinner. So it's so simple. You see, it's not anything complicated. These are all simple events. Now, let's consider I have a dime, I have a penny. Okay. This is the way I'm doing. I flip a dime, then I flip a penny. Am I making sense? Now, this was a simple event, but I combined this simple event with another simple event. I did both. Right? Now, what is the sample space? Please, I will show how to write the sample space and then you can start writing, okay? You know what I do? For the first event, right? I write out what are the possible outcomes, head and tail. Now the second event. For the first event, after throwing a head, right? Suppose it ends up with a head. What are the two possibilities for the second event, head and tail? Suppose if I throw a tail in my first event, again the possibilities are head and tail. This sort of drawing a diagram is called a tree diagram. Makes sense, guys? Now, how to write out the sample space for this? This becomes a compound event. You get it? So how to write out the sample space? H, because first event, second event. HT, TH, TT. Makes sense? So how will you know the number, sample space? What is the size of the sample space? How will you say? Two options on my first event, two options on my second event, right? I am flipping a coin, head to tail. So multiply the outcomes. So the size of the sample space should be 4. Make sense? We are learning a lot slowly, but I don't know how much we are getting. Let's see. Now, suppose if I flip a coin, throw a die, throw a 6-sided fair die. In this scenario, what should be the size of the sample space? Anybody can shout out. We are trying to interact. What should be the size of the sample space? Any thoughts, guys?
Wait, what is the sample
What is
space?
the size of the sample space? Sample space means outcomes, right? This is a compound event because I'm doing two things. What are all the possible outcomes for this one?
Is it 8?
What did you multiply or add?
I add.
But this one, see, this two options, each one will have 6, 6, right? You see what I mean?
Yeah.
After throwing a head, I can end up with 1, 2, 3, 4, 5, 6, right? Sayush, are you with me following? Are you?
Yeah.
So basically what I do, I flip a coin. Okay. When I flip a coin, I can end up with a head, right? Or I can end up with a tail. Both scenarios I need to cover. Considering I end up with a head, the die can result in 1, 2, 3, 4, 5, 6. Considering I end up with a tail, I can end up with 1, 2, 3, 4, 5, 6. So, what are the possible outcomes in this both experiment? It can be a head and a 1, head and a 2, head and a 3, head and a 4, head and a 5, head and a 6. Or I could have gone for a tail option, tail and a 1, tail and a 2, tail and a 3, tail and a 4, tail and a 5, tail and a 6. So how many, what is the size of my sample space? 2 times 6. So it has to be a 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Wait, so is it basically like the outcome of the first one times the outcome of the second one?
Correct. That's what I conveyed. Good job. Yes. Make sense? So how to draw this tree diagram? List out the outcomes in the first experiment. Each one will point to all the possible outcomes of the second one. Make sense, Nidhi? Are you?
So wouldn't
Bharat?
it be 1/12?
No. This is not probability, please. We are not doing any probability now. We are just counting the sample space. Sayush, I did not ask you for any probability here. I just asked you to please write the sample space for this experiment. Make sense?
Yes.
Okay, now let's go ahead and see. How about I have a spinner? You're going to write out now, okay? The spinner has 4 pieces. 1, 2, 3, 4. Okay. And then I have a coin. Okay. Flip a coin. Guys, I really want you to tell me the sample space. Please write out the sample space. Also tell me the size of the sample space. Can you do this? I want to see how many of you are doing it. If you didn't understand, it's really okay. I'll go over it.
I don't get what you're saying to answer.
Okay, whoever understood, right? I want to see who all understood.
I understood it, so should I send it in chat?
Yes. Who will be able to tell me the sample space for this experiment, for this compound event? Wow, Anya, perfect. Varad, you're only counting this event, right, Varad? See, okay, what do you mean by spinning the spinner? You can end up getting 1 or 2 or 3 or 4. Those are the possible outcomes. I'll write that down. This is for event 1. In the event 2, what happens? Flip a coin.
They'll get a random chance of getting select.
Yeah, what are the possible outcomes in this?
Heads or tails?
25%.
Head and tail, yeah. But then in the event 1, you could have spun the spinner to a 1, and in event 2, you still can get a head or a tail. In the spinner, you could have gotten a 2. I'm trying out and listing all the possible outcomes. I could have gotten a 2 and then get a head, or I can get a tail. In the event 1, I could have gotten a 3 and then get a head or a tail. Mitransh, 1 minute. Yeah, Mitransh, that's correct. The second one is correct. Fourth can be a head or a tail. So how to write out this outcome? 1H, 1T. See, I spin the spinner, flip a coin. 1H, 1T, 2H, 2T, 3H, 3T, 4H, 4T. So that is your sample space. Sayush, did you get it now?
Yes. Would it be okay if we ended up doing 1H and then 1 and then like 1H and then 2H and then 3H and then 4H and then
Perfectly fine.
1T?
The size, perfectly fine. The size should matter. There is 2, what is this? This is 4 times 2, right? 8 should be there, that's all.
Okay.
Vikyat, are you with me?
So for the
Yes. Well,
size of
1
the
second. I'm just fixing something my setup.
Adyan, Riddha, are you with me? Last
so
year, you
Miss
ma?
Priya,
Mm,
so the size of the sample size is 8.
correct. Very good job.
Okay.
Make sense?
Yeah.
Yeah, I really want to ask you more questions now. Hold on. So basically, now I'll ask you, wait. Okay, this is what I want you to know. Okay, So your homework will entail anything around coin tossed probability, or it can entail sample space. So how about this? Okay. How about this? This is a tricky question. Let's see. Let's see. How about this? Suppose roll a six-faced fair die 90 times. How many times you can expect to get a 5? See, guys, hear about how many times can you expect to get a 5? See, when they ask you for probability, please, it's a fraction. Okay, less than 1. Okay, when they ask you for the number of times, it's different. It's a whole number of times they're asking. Please, everybody confuses this in 7th grade. So let me tell you, if you roll a 6-face die 90 times, so 1 by 5 is the probability, but 90 times, so what happens? Okay, it's okay. 18. Did you get it?
It's 6 times.
because
It's 1 by
there's
6.
six
Oh,
faces on the die.
Yeah, it would be 15. It'd be 15.
Agree. All of you are getting it right. I got it wrong. Make sense?
Yes.
Okay. Can I move on? But please understand, don't answer as 1 by something, or don't answer as a fraction when you're asked for the number of times. Please see what is asked. Okay. Every time I see 7th graders answering the other way, probability is a fraction less than 1. But if you're asked for the number of times you expect yourself, it's going to be a number. If you have a fraction, then some understanding is incorrect. Can I move on? Okay, I'll ask you some different questions. Let's see. Yeah. How about this? You have a jar containing 5 red marbles, 4 green marbles, 2 blue marbles. What is the probability of getting a blue marble? See, I'm asking for the probability now. So clearly your answer has to be a fraction. Good job, guys. Good job, guys. All of you got it right. Whoever sent got it right. But please don't make me pull you out, rather call you out. It's not nice, right? We're all working together to Adyan. I told you, right? Don't give me a number when you are asked for the probability. Don't give me a number. It has to be a fraction.
Yeah.
So probability means number of favorable instances divided by the total number of outcomes. You get it? Lasya, are you understanding?
Oh, I actually messed up on my addition.
Lasya, I didn't get an answer from you. Nidhi, I didn't get an answer from you. What is going on?
All right.
Lakshmita, Varad, did you get it? Vikya, Varad, did you get it? No. Okay. Can I help you? Bharat, did you get it? Hey, we are not able to hear you. I'm sorry.
Yeah, hello, can you hear me?
Yeah. Go ahead.
Okay, so I didn't get the like whole question, like the answer of the whole question. Like how'd y'all get it or something?
What is the probability of picking up a blue ball?
Priya,
Yeah.
I have a class, so can I go?
Yeah, ma. Yeah, another 5 minutes I'll go over, Ashwik. After that, I'll finish. Yeah, you go ahead.
Okay.
You understood the basics, right?
Yeah.
Go ahead.
Bye.
Bye. So 2 black balls, right? Two blue balls, right? So number of favorable instances, 2 blue balls I can pick up. Out of how many in total? 11. Do you get it? So my probability, the chance of getting a blue ball is 2 out of 11. Varad, did you get it? Varad,
Yeah,
did you understand that?
yeah.
Okay. Okay, how about this? This arrow is spun, the spinner is spun 60 times. How many is spun 60 times? How many will be an odd number? 1, 16.
Nobody's in the theater right now. I gotta see that.
How many times will it be an odd number?
Hey, we're heading out.
This will end, guys. So basically, let me solve this problem and get you conclude the class. So if you're spinning 60 times, right? Odd number is 1, 2, 3. So 3 out of 5 is one time. If you spin it, 3 out of 5 is an odd number. That multiplied by 60 is 36. There is no percentage, Lakshmita. How many times? Did you get it? Okay, guys. So basic problems I'll give you. Can we stop here?
Yeah.
Okay, guys.
Sure.
I'll give you only basic probability puzzle, 2-page puzzle as homework. Okay.
Okay.
Yeah, guys. See you all next week.
Bye.
Bye, Miss
Bye,
Priya.
guys. Bye, guys.
Bye.
Bye.
Bye, Miss Priya.
Bye.